I messed up. I had this table that groups states into regions. One day, the company decides to realign a state to another region. So, I update the database. New York used to be in the Northeast region, but now New York is in the Atlantic region. No big deal. Until the CFO comes and asks questions. He's wondering why his historic report is different. The totals by the region seem to be off. At which point I tell him, we have no record that New York was ever in the Northeast region. We lost that when I made the update in the database. That's when I felt the pain of poor data modeling. The cure for that pain? Slowly changing dimensions, SCDs. Today we'll see how to update our tables while still keeping tabs on historic data, so you don't have to face the CFO's fire like I did. Let's begin. First, a little bit of background. In the world of data modeling, there's something called the Kimball data model. The Kimball model features a fact table linked to many dimension tables. Fact tables describe events. Rows in a fact table might be a transaction on Amazon.com, or it could be the event of someone checking in to a hospital. Here's a sample fact table that shows encounters at a hospital, where each row represents a patient's interaction at that hospital. We can see, for example, that a certain patient checked in on a certain date. While they were there, they received a diagnosis and a treatment that cost some amount of money. Neat. But what do all these codes mean? Who is patient 001, and what are these diagnoses and treatment codes? That's where dimension tables come in. While fact tables represent events, dimension tables represent things. We can join these two kinds of tables, facts and dimensions, to get the whole picture. For example, we can join this fact encounter table to our patient dimension table. Specifically, we can take that patient ID from the fact table and join to the ID from the patient table. Doing that, we can see the patient's name, their birth date, the address, and all the other things that you would need for identity theft. Here are a few records from that patient dimension table. We can see finally that patient P001 is Mr. Potter, who lives at 4 Privet Drive. If we want to find out more about the diagnosis, we can join that same fact table to the diagnosis dimension table. But this time, the join would be on the fact table's diagnosis code to the dimension table's ID code. And there, in the dimension table for diagnosis, we can see descriptions of that diagnosis. This is what I mean by fact tables being joined to many dimension tables. The fact tables describe events, and the dimension tables describe the things involved in those events. But what exactly makes a dimension table slowly changing? Well, most of the time, dimension tables don't change. It's very rare for someone to change their name, and near impossible for them to change a birth date. But every now and then, there is something in a dimension table that changes. Hence the term, slowly changing. SCDs have different types or frameworks on how to update a dimension table when something changes in the real world. These types give us a way to look at the current value of the dimension, and some also give us a way to look at historical values. Let's check out some of those types. SCD Type 1. In Type 1 tables, the new info replaces the old info. Whenever something changes in the real world, we simply update the database, overriding the old record. I had a Type 1 slowly changing dimension when I foolishly updated the region for New York. Here's how it works. In our current patient dimension table, Harry lives at 4 Privet Drive. But one day, he's going to inherit his godfather's house at 12 Grimald Place. The update would look like this. We would simply replace the address with 12 Grimald Place. This approach gives the current state of the dimension, but we lose historical records. And when the CFO inevitably asks for a historical report, we're cooked. We have no idea of knowing where Harry lived before 12 Grimald Place. That said, there is a place for Type 1 SCDs. Type 1 tables are useful when you don't care about historical analysis. Sometimes only the current value matters, like when you need the contact info for your customers. Type 2 SCDs are their next level. When a change occurs, instead of updating the existing record, we add a new record. When Harry's address changes, we go from a dimension table that looks like this to one that looks like this. We insert a new record with that new address. Great, but now we have 2 records for Harry in this dimension table, and when it's time to join the dimension table to a fact table, it's unclear which of these records we should use. That's why type 2 tables have helper columns to tell us when each version of the record is active. For example, the start date and end date columns outline the window of time when each record is active. If Harry's address changes on June 30th, 1996, the type 2 dimension table might look like this. The first version of the record is active from Halloween of 1981 to June 30th, 1996. The start and the end date columns tell us that. The second record is active one day afterward, beginning on July 1st, 1996, and ending on December 31st, the year 9999. This high end date is a convention to show which record is current. It's useful when filtering records using sequels between statement. When you take a dimension table like this and join it to your fact table, your SQL query might look a little bit like this. Like before, we're still joining our fact and counter table to our patient dimension table on the patient ID, but this time we're also ensuring that the fact table's encounter date is between the patient table's start and end date. This captures the proper version of Harry's record when he was in the hospital for that encounter. Again, this fake high end date is a way of showing which record is current. Instead of this date, you might also see a null value, which kind of makes sense. If the record is current, it doesn't technically have an end date. But there are other ways of showing which record is current. For example, you could add another column to indicate exactly that, which record is active. We could add a Boolean column called isActive, where false is given for rows that are no longer active, and true is given for rows that are active. Alternatively, we could create a version column, where every version gets a numerical value that increments by 1, and the row that has the highest version is current. The methods of identifying the current row go on and on. The beauty of Type 2 SCDs is that each version of a record gets its own row. This gives us a full history of all the changes, which enables historical analysis. The downside is that multiple rows represent the same thing. Here, we have 2 rows that represent the same Harry. So in using Type 2 SCDs, we need to be careful to filter for the version that we want. By the way, if you're enjoying this, check out my newsletter. I share engineering tips and personal updates twice a month. You can sign up by using the link in the description below. Now back to the show. Type 3 SCDs. Spoiler alert, I don't like Type 3, but here we go. When a change occurs, Type 3 tables don't add a new row like you did in Type 2. Instead, new columns are added to indicate the old value and the new value. The first time a change occurs, the address column is renamed to original address, and we also add new columns, current address and effective date. The old and the new address are in the original address and current address column respectively, and the effective date column tells you when that current address goes into effect. This approach bakes the historical value in the row along with the current value. However, there are 2 cons. First, Type 3 SCDs track limited history. When Mr. Potter moves again, we'll update current address and lose track of how he once lived at Grimmauld Place. We can only record the original address and whatever the current address is. Second, the column count can explode. Here we're tracking changes to address, so we have 2 columns to do that. But what about other columns? Should we also add original and current versions of the last name column, the phone number, the marital status? Quickly, the number of columns can become too wide. For this reason, Type 3 SCDs are useful only to track one prior value for a couple of columns. It should not be used for full historical tracking. Alright, Type 4. This is where we part the waters. Type 4 uses 2 tables for the dimension, a current table and a historical table. Unsurprisingly, the current table has only the current version of each record. The historical table has all versions along with the timestamp of when that version became active. This is our before state. When a change occurs in the real world, the record in the current table is updated and a new record is added to the historical table. When Harry inherits his house, we can see that his address is updated in dim patient, the current table, and a new record is added with that new effective date for 12 Grimmauld Place in the historical table. Type 4 SCDs keep the current dimension table small, which makes it faster for querying. We also don't have to worry about multiple records representing the same thing like we did in Type 2. Here, in this Type 4 dim patient, we only have one record for Harry. And for those few times we need a full historical analysis, we can use the historical table. Like any good Pokemon, SCDs continue to evolve to Type 5 and Type 6, but I've never seen them in practice. Most of the time, engineers are happy with just Type 1 or Type 2. Let's review the types we have seen. Again, slowly changing dimension tables describe things. They're designed to reflect the current value, and some also give you a way to look at historical values. When a change occurs in the real world, each type tells us how to update the dimension table differently. With Type 1, when a change occurs in the real world, we simply update the record in the dimension table, replacing any historical values. With Type 2, a change in the real world means we add a new record to the dimension table, and there's some helper columns like the start date and the end date to tell us when each version is active. With Type 3, we do not add a new row. Instead, we modify the original record, and we have an extra column to tell us what the old value was. Type 4 uses two tables, so when a change occurs in the real world, we update that current table, and we add a new record to the historical table. And that's it. Each type has its use cases. There is no good or bad type, except for Type 3. Type 3 sucks. I tried to keep these data models in mind when designing my data warehouse. On day one, the data warehouse is perfect, but the business will change and unexpected things will happen. Designing my tables well at the beginning has spared me a lot of headache, and I hope this info helps you. If you have any data horror stories or questions, drop them in the comments below. If you like what you see, please like and subscribe. And until next time, happy coding.